Okay, so today let us build some image, right? And yesterday we have looked at 4 instructions. Actually, we have not understood what they are, but we have looked at 4, right? We have seen something like from, we have seen something like run, maintainer, and then the last one was CMD, right? So I'll basically explain what they are, and then we all have $1 million question: what is inside that container? Till now I have not discussed about it. What is inside the container? We will look about it, right? So first, to the guys over the web, am I audible? Wonderful. Yeah. Okay. So our motive is create a basic image, right? And then understand how containers or Docker work. So these are the two important motives. And after that, it is all applying these concepts throughout for different phases or different aspects of your computing, right? Okay. First, create a basic image. It starts with the instruction which is called as from. Okay. From is selecting base or parent image. A container cannot be started or cannot be created without choosing other container. So from, whenever you select, you choose some existing container and on top of it you do something. So for example, if I want to start with something like Java or Tomcat installation, for Tomcat what should be present? So if I have any container where Java is already installed, then that is the right place for me to start. So for example, if I'm looking out for any website deployment, okay, so I'll be taking a container which already has an Apache or Nginx, right? That will be my from image. So that's the whole concept. Or if you don't want all of this, you can use something called as from scratch. From scratch. Whenever you say from scratch, what would happen is you will just get the basic Linux file system, very basic, and on top of it you have to do everything. So either you can start from zero or choose existing and then get the stuff done. That's your choice. There is nothing called as this is the right way to do, right? So for example, if I want anything, choosing the base image is also an important activity, because based out of it I will have some steps. Based out of it I will have some steps. And generally we build container or Docker containers for applications, right? Yes. Okay. So from is all about that. There is something called as maintainer. Okay, these days they are changing it with label also. So maintainer will tell who is the creator of it. You will write your mail ID or username, whatever, that makes sense. Not a very good great deal. Run. Okay, this, or I should say these are the commands executed during building image. Whatever you write in run will be executed when you are building the image. All right. So for example, I want to build the Tomcat container. My run should do the steps which should bring Tomcat into that. So run are the instructions. Okay, it will consist of commands which will basically be executed when you are building the image, right? And then at the last, there is one more thing, but I'll just stay back to whatever we have seen yesterday. CMD is executed when container is created. What is the difference between 3 and 4, or run and CMD? What do you think is the difference between run and CMD? Okay, run is something which will be executed while you are building the image. Then when will the cmd be executed? So what command is that? Whenever you execute docker run, cmd will be executed. Whenever you execute docker run, that run will not be executed, cmd will be executed. So whatever you write in that cmd is the set of commands which you want to run when your container is being created or starting. Right? Fine, simple, not a very great deal, right? We have from where we choose our parent image or a base image, and then maintainer is all about you. You write your email address or whatever your company has given to you as a recognition, and then you would have run statements. Run statements are the commands that are executed while building the image, right? And then we have cmd. Cmd is something that would be executed while you are starting your. Okay, now whatever you have written in the cmd, whatever you have written in the cmd, as long as that command is working, as long as that command has not completed, your container is alive. Container is alive till the point cmd is executing. Once the cmd has finished its execution, then the container will die. So let me tell you what is the difference. I do this echo hello. So is this command finished? So if I put this in the cmd, it will print hello and container will die. It will print this and the container will die. Now do you understand why docker run hello world dies immediately? Because there is a command in the startup there which has a job of just echo statements, and once that echo is finished, your container will kill itself. Right? Or here if I write a command, okay, which is executing forever. So for example, if I do this ping google.com. So now what happens? It executes for some time. Till this ping command has not returned, your container is alive. Once this ping is finished, your container is dead. So the commands which you are writing, okay, depends or determines the life of your container. Determines the life of your container. Okay. So command is not the only thing. There is one more thing which you would be learning very soon, which is basically called a start point. Okay, but whatever it is, whatever commands that are run during the execution or starting of the container, as long as they are alive, your container is alive. As once they have finished their execution, your container is dead. That's as simple as that. Right? So let us try to do the couple of things. One is basically the command which kills, which finishes immediately, and the command which does not finish anytime. Shall we try that? Yes. Okay. So but I'll be doing all of this on the Linux machine build, because I'll be writing a very basic image. My image will not have much of installations. I'll be taking some basic image and doing some activity. Right? Okay. So let me do this. Yeah, we have our machine in AWS, right, which we have installed. Copy this, go to the folder wherever you have PEM file, open git bash here, and blindly paste your command. Yeah. So let me create a folder over here. Okay. So let me call it as images. Okay. I'll be creating one more folder which I'll be calling it as okay. So the file which you are going to create for creating the Docker image, it could be anything. The file can have any name. right? But whenever you are following a name which looks something like this, the name of the file is equivalent to Docker file, then you don't need to execute extra commands. Then you don't need to execute extra commands while building the image. Otherwise, you have to use an additional command line argument called as -f and tell where is your file, right? And trust me, all the people in the enterprise try to create a Docker with this name itself, because this was a restriction in Docker earlier. When Docker started, the name of the file has to be Docker file. Now they have removed that restriction, but as a convention, people still try to create the images which has a name which is Docker file itself. All right. So let us all stick to only Docker file, not other files. Are the other files not possible? They are definitely possible, but for that you have to use the additional command line arguments. Okay. So now let me write my first Docker file. Okay. Vi Docker file. Okay. D is capital, rest of all are small. From, I have to choose my base image. I have to choose my base image. So base image could be anything based out of your requirements, right? So for now, I'll be taking Nginx. Simple. My from is Nginx. Okay. And then maintainer is me. All right. And then run. And whenever you are executing the run statements, the problem here is we will be executing the commands of Debian based operating system, or which is a Linux distribution or Red Hat based operating system. For that, you need to know what is your parent. Is it a Debian based or is it a Red Hat based? What commands execute there? All right. So always, what do you think is a better way? Before writing it over here, test it once. Yes. So shall we test in the Nginx container the commands which I want to execute? Make sense? Right. So I'm just saving the file till this point. Okay. I'll execute my test and then I'll execute whatever commands are necessary over here. So Docker run Nginx. All right. You can do this. All right. Or you can say that while starting the container itself, take me into the container. I want to get inside the container. So there are a couple of ways of doing it. One is, the first way which I want to show is use something called as -it. -it is interactive terminal. Okay. And then give the name of your container, Nginx colon 1.14 or Nginx colon 1.14 colon Perl, whatever base image which you have, right? And you need to tell where is your terminal. So bin slash wherever your terminal is. If you don't want bash, if you want some other terminal, ZSH and all of that, give the path of it. Am I inside the Nginx container? How are you telling that? So here, what is it? Sorry, host name or username at the rate machine's name. After this line, what is it I am seeing? Root at the rate some name. So root is the username which you have logged in into your container, and whatever ID which you are seeing is your container's name, right? So now let me see. ls working, ping. All right. Ping command is not found because this will not contain anything which you want. This will contain only the things which are required for Nginx to work. So let us get into the Nginx stuff. cd var okay. We don't have this. So let me get into cd var. Fine. We don't have anything. As I said, I'll not be doing a wonderful container over here. The only thing which I'm trying to do over here is create a simple text file. Create a simple text file. Now I'll be creating a text file. Actually, you might be copying your application, complete application going forward, right? So within the container, so how do I create my text file? I'll be using touch command. Touch test.txt. Make sense? Working, right? That's it. This is my run statement which I want to run. So touch command is working. Whenever you are executing any run statement, please be very clear. Get inside the container and see, because a very basic command like ping is also not available. A very basic command like ping is also not available. If you want, there in many containers, even this will not be available. Okay, it will have very core commands. Can't I get it? Yes, you can. You have to install it. Will I not get ping over here? You will. But the problem is you have to install it. You have to add it to your run statements. Container should be as much small as possible. Container should be as much small as possible. For running a Nginx, what is the need of ping? Nginx run and ping kavala. That's how the containers are designed. They are just designed to be as much minimal as possible. Right? So now I want to get outside of this container. Use Control C. Oh, not coming out. Oh, sorry. Exit. You don't need to do all of that. Control C is when you are running in the attached mode. Right? Okay. Now, Docker PS. Is the container still running? Oh, I think we don't know it, right? So that's fine. I'll show you it the later point of time. I want to kill all the containers. How can I do that? Docker RM and give me the list of all the containers. Docker PS. Okay. I want to kill only the running containers. Then don't use -a. -a will give you the history of all, and I want to kill just the running containers or remove all the running containers. So I'll be using Docker PS -q or -q. Since I am executing on running containers, I'll be using minus. So if you want to remove all, in that statement you'll be using PS -a -q. I want to kill just or remove just the running containers. So that's why I'm not used -a. There you can apply whatever logic which you want. Right? Okay. Fine. Now let us go back to our Docker file. So vi Docker file, and my stuff is very much simple. So what is that I'm going to write? Terminal is struck. So yeah, good. Yeah, fine. Now here I will be saying touch test.txt. That's it. This is my building stuff. Is it a very huge stuff? Not. But whatever you are going to do, okay, it is basic Linux commands are what you are trying to execute over here. So we'll follow that approach. And now, what do I use in my CMD? In my CMD, okay, I can write Linux statements itself, but I'll be using something called as array notation. So what is the first stuff? Echo. And what do you want to print? My first image. Make sense? ఎవరన్నా రాయొచ్చు ఇది, దీనిలో పెద్ద గొప్ప ఏం లేదు ఇందులో. So what is that I've done? I've just taken the base image which was an Nginx, and then maintainer is not a very great deal, right? It is just metadata, and then I have used the run statement. And what was my intention? My intention was to create a file. Okay, but remember, I have not given the full path. If I was doing it generally, I would have given the full path. Ideally, you should be using only full paths in the case of Docker, right? Because you don't know where you will be. All right, in this container will be in the root folder. In some containers we might not be in the root, we might be somewhere else. So whenever you want to create files, please know the complete path. Please know the complete path. All right, make sense? Not a very great image, but it's okay. To start with, this is a better stuff. All right, good. Now I want to build the image out of it. I want to build the image. I have written the Docker file and now I want to build the image. And whatever I have written in run will be executed while I am building the image. So to build the image, the command is Docker build, and minus T will tell you name and tag of your container. Name of my container, I want to give it as my underscore first. Okay. And tag, I want to call it as, we know what latest is, right? And the next argument which you need to tell is where is your Docker file? Where is my Docker file now? In the same directory? Yes. So I'm using dot. If it was in some other directory, I would have given the path of that directory over here. Right? Simple command, Docker build minus T, name of your image, colon, whatever version which you want, whatever tag which you want to give, and then where is your Docker file? So see what is happening in step 3 by 4. Yes. Now let us ask our local repository, do you have, what are the images which you have? So how do I ask that? Docker images. Are you seeing any image which you have built right now? Yes. What is the size of it? 109 MB. What is the size of the image which we have taken? Nginx latest? Yeah. Same thing. If you see, our size will always be greater than or whatever run statements which you have done plus your parent container, parent image. My parent image was 109 and I've created the empty file. Touch will create an empty file which will occupy almost no bytes, right? So the size is exactly the same. But if you have copied a file which was 10 MB, your image size would have been somewhere somewhere closer to 1.109 MB plus whatever you have done, right? In this case, I have not done anything. I have created an empty file. So that's why size is still 109. Make sense? So shall we run our container? Right? So to run the container, what is the command? Docker run. Okay. Your container's name, your image's name, sorry. Right? And then click enter. This will see what it does. It has basically whatever I have written in the CMD was executed. What is that I have written in the CMD? Echo my first image. So are you seeing my first image being printed? Will this container be still running? Why? Because the echo command has returned, right? In there, if I have written some script which will run forever, then my container will not die. Then my container will not die. So the lifetime of your container depends on what you have written during startup. What you have written during startup. Let me tell you what is the best way to do that. Let us assume that I am running an application. Let us assume I am running an application. My application is an e-commerce application, right? So now whenever I run, a process will be created. Do you all agree to that? Whenever I run any application, a process will be created. So my container should be alive as long as a process which is running my application is still working. My container should kill immediately, okay, when the process has stopped working. So let me tell you a basic logic around it, how people tend to write it. So let us assume this. Are you seeing a notepad process here? Let us assume that I am writing something in the startup of the Docker container. Okay. So I will write something which will see what is the process ID for whatever application which you have created. So what is the process ID? 4264. And this command will be executing as long as 4264 is running. For some reason, if 4264 dies, right, this command will return. That means your container will die. Did you got the logic there? Right? For this, there are some already existing stuffs, and in some cases, you have to write something like that. And whenever you want to write something like that, you should be good at shell scripting, Linux scripting. Right? In Linux, you have to wait for the first you need to get the process ID and wait for the process to be killed. Right? So that's your logic over here. But let us not worry about. We'll be dealing with that. Is it simple? Right? So now, if you have to write a complicated application, what changes? Your from changes, your run changes, and then your CMD should be equally good. If you are good at all these 3 points, rest of all the things are additions to this. The complicated containers which we are going to write going forward are additions to these things. Right? Simple. But have you observed one thing? When I get inside the container, I was still seeing Linux. Right? Yes or no? Yeah. If you remember my points, I said that whenever you create a Docker container, what you minimally get is a Linux kernel. What you minimally get is a Linux kernel. So within any container, some basic Linux commands will work. When I'm speaking about Linux containers, let us not bring in Windows over here. Windows will deal at the later point of time. Okay. Whenever we are bringing in any container, we will see some terminal there, right? And in that terminal, you can work some basic commands. So to do anything in Docker, you don't need to be good at any programming language, but you should be good at how to install your application from your CLI, from your command line interface, from your terminals, because that is what is required when you are building an image. Yes or no? Right? For example, I'll take a question. Yeah. For example, if I have done that, let us assume that you want to install a Tomcat application. I will never be able to write a Tomcat image if I don't know what are the steps to install Tomcat from CLI. Right? And there is one catch over here. Whenever you are using these commands, okay, sometimes when you execute a Linux command, you will get a prompt saying that do you want to continue, yes or no. Right? If you have written any command in run which will expect user input, Docker creation will be terminated. It will not create anything. It will be failed. So we have to write the commands in such a way that it will not expect user input. It will not expect user input. For example, okay, I'm just trying to detail it out. So for example, I do this apt-get, okay, sudo apt-get install tree. Okay, tree is a very simple thing. What is the other thing? Nano will already be there. Okay, let us install Java here. Sudo apt-get install open JDK. No, what is it? Open JDK. Let me do this. Sudo apt-get install, because I don't want to run this command. I want to just see that prompt. Are you seeing this? It has asked me saying that do you want to continue? If I have written the same statement in run saying that sudo apt-get install Tomcat 7, my image creation is failed because it is asking for user input. So to avoid this, the Linux way is you have to write something like sudo apt-get install Tomcat 7 -y. That's the whole point. So you will be writing very basic commands, that is for sure. And in the basic commands, the other thing which you need to take care is it should not ask for user inputs. It should not ask for user inputs. As long as you take care of these two things, you can write any image. You can write a Docker file for any image. Rest of all of the instructions which we are going to learn are something which will help us on top of whatever we are learning. Right? I don't want to install Tomcat, so that's why I'm saying no. Right? Because my motive is not installation. Okay. So what is the care which we need to do? First is you need to find the right base image. Second is you should know what are the steps which you are trying to execute. And to execute any of these commands, you just get inside the base container and execute them manually before you write them. So for example, if I want to execute any instructions in the run first, what I would probably do is I would say docker run -it, my base image, whatever I have to choose, /bin/batch, which will take me inside that container. And then whatever I want to write in the run, I'll be executing there manually first. If all of them succeed, then only I'll be writing it in the Docker file. Did you got the steps which I'm trying to tell? ఏ పని చేసే ముందైనా ఒకసారి మాన్యువల్ గా ఎగ్జిక్యూట్ చేసుకు చూడండి. Don't trial and error you will be able to do once you have built some images. So for example, you have built already 10 to 15 images, then you don't need to do this stuff. You will understand, okay, if something goes wrong. But initially my recommendation is get inside the container. And how do we get inside the container? You will execute something like docker run minus it. Okay, minus it is an interactive way of executing your containers, and then whatever name of your container is, right? And then I'm writing bin slash bash, but for the people who know Linux, that is not the only thing. You can give any terminal path. You can give zsh, you can give sh, whatever that makes sense to you, right? Are we good? Get inside the parent container, execute your run statements manually. Yeah, only when they are successful, write a docker file. If they are not, that means your docker file building also will fail, right? So docker build image doesn't do anything. It will take the base image, it will go into the terminal, it will execute whatever you have written in your run statements. You will execute whatever you have written in the run statements. Is it making sense? Right? Okay, so before getting one level deeper into this image creations, it is very must and should for us to understand how containers are working, so that we can write our images better. We can write our images better. So my next topic of discussion is how containers are working. Before that, I'll take some few questions. I'll not take complete stuff because we have to discuss on important aspect. Yes, you had a question. Excuse me, ma'am. You had a question. Yes, your image creation will be failed. Yes, yes. Logs, you will get logs. Yes. Okay, the question was, if the command fails, will we get any information back? Yes, Docker has a decent logging stuff. Okay, you will have logs. Right. How can we do capacity planning of the container? Yeah, we can do that once we have correct images. Okay, there are certain concepts which I'm going to discuss right now. In the next stop, I'll be discussing some of the commands or some of the concepts which will help you to do capacity planning. And remember, capacity planning we don't do on disk, we do on RAM. Ground principle. Even in virtualizations, no one is doing capacity planning on hard disk now. Basically, we do on the other compute capabilities, right? So we'll be doing that. How many processors do I want? Generally, these are the kind of capacity plannings we do. How many processors do you want, and what is the RAM which you think do you want? All right. So Docker has improvised a lot from the day it was. Initially, when we started Docker, when you used to run the Docker always to work with fixed memory. So whenever you use a Docker command, a default container will consist of a memory which was 256 MB. But now that is not the case. Now Docker has also become intelligent. Now what it does is, it depends on your system's memory, it will choose whatever is required. Whatever is required. Okay, and it changes also. Right? That's how it would work. Fine. Can you please create AWI image? What is AWI? Please don't use abbreviations. I'm very bad at that. All right. Okay. So can we use direct commands, docker start, kill, etc.? There is not kill. Kill is remove itself. You will have docker start, docker stop. Okay. Fine. So why the bin bash is given at the last of the command? Okay. So first thing is, we have said interactive, right? And the next thing is, you need to tell where your interactive terminal is, right? That is the path of your interactive terminal. That's why we have given it at the last. How to log in into the container via SSH? For that, you need to know how to log in using SSH. What are the different things which you need to know? I need to know IP address. I need to know username and password. All right. Since I don't know it, I'm using the much easier way. Right. If I know username and password, if I've created a Docker image which has some username and password, you can use the same SSH command and install SSH service inside your Linux machine, because by default you will not have an open SSH server running and all of the stuff happening. Don't expect it to be a machine. It is a very thin stuff. So to prove that point, I've shown that ping command is not found. If config is not found, your containers will not have whatever your Linux machines will have. It will have a very limited stuff, whatever is required for your application to work. Can't you do that? You can definitely do that. But for that, you have to do your extra installations. In the run command, go ahead and install SSH, whatever is required for the SSH services to be started. Right? Okay. So, yeah, I think that's what we had. Now let us get into the interesting area of it. How are these containers working? Okay. Yeah. Fortunately, it is open. Good. How containers work? So this is how a physical machine works. Any I'm not saying, when I say physical machine, I don't mean not in the case of virtual machine, but if you take an general OS, let it be physical or virtual, what would happen is you would have your CPU intense resources, whatever they are. On top of it, you would have operating system, and every operating system will create something called as user space. I'm speaking about Linux, not Windows, right? It will create something called as user space, and within that user space, all of your applications are working. Within your user space, all of your applications are working, right? So this is how basic stuff works. Now let us see how about container. Container will create multiple user space. So each container logically is a user space, is a user space, and within that user space you can run your applications. Okay, each isolated user space is your container, right? And in that we will be having whatever our application has required. So is it isolated? And remember, a user space cannot speak with other user space. A user space cannot control other user space. The only thing that can control user space is operating system. Okay, Docker will try to create something which looks like this, or any container technology for that matter. Let it be Docker, Rocket, LXCs, anything. So what is a container now? Container is an isolated user space. Still confusing, right? So let me tell you what happens in Linux. How many of you used a concept called as guest login? You will not have username and password on this machine, but you can click on guest login and you can get inside that, right? From there, can we hack Linux? Yes or no? No. If it is Windows, yeah. If it is Windows, whether you are a guest user or any user, your C drive and D drive are still the same. But you try to log in as a guest user on a Linux machine, you will not have the same look and feel. You will not be seeing what that other folders views are, what are the other processes that are running, right? You will not be able to see all of that. In Windows, you basically get C drive and D drive. Yeah, whether you will be accessible to that or not is a secondary story, but you will definitely be able to find out that okay, there is a C drive and there is a D drive and these are the contents, right? But in Linux, you will not even get that. So every user space will get its own view of what the file system are, its own view of what are the processes. So this, let us assume that this is a user space. We have two user spaces over here. For guest user, I have created one more user space. That user space is altogether a different boundary that will not know anything about this. That will not know anything about this. So this concept was created for basic what do you say, guest logins in the Linux from day one. Okay, and they said that whenever you want to use this guest login or anonymous login, they were very sure that the anonymous login should not know what the actual logged in users are doing. So that's why they have one level of abstraction which they call it as user space in Linux, right? So what is a container? Technically, container is nothing but a isolated user space where you have your application. Now I have these many user spaces, and each user space will not know what the other user space is. If the user space wants to communicate to the other user space, the only way is how you communicate between two machines. How do you do that? Using IP address, using networking. Same thing here. There is no direct contact, right? An application which is in this user space cannot basically do anything about the application which is running in some other user space. It will not know anything. The only way for them to communicate is by using IP addresses, by using port numbers. That's it. Okay, so they will not have anything in common. Every user space will get their own privileges. So they cannot control anything which is outside that boundary. Okay, this is a concept which container has used. So in container, technically what is that you are creating is a user space. Okay, and user space scope is only the application scope within that user space is only till the user space boundary. So for example, I have created two applications within that user space. Yes, they can speak with each other. They can do everything in common. Anything that is in this user space can be shared, right? In Linux, whenever you are logging in, you have a user space for the complete Linux system. But here we are having a user space for every application which you are developing, which means that user space is not something like it will share some of the operating systems stuff. Yes, it will share. It will share. It will share physically, not logically. It will share physically, not logically. What do I mean by that? Right? So every user space will get their own file structure or their own file structure. For example, to tell Windows terminology, let us assume that you are in user space 1. Okay, you might see drives like C and D. In user space 2, the user might not like C drive. We might use something like F and G. Okay, they are logical stuff, they are not physical stuff. C and D drive and F and G drive of the user spaces are not physical, they are logical. Okay, whatever you do there will speak with the operating system and get the work done. Okay, similarly, whenever you do control shift escape or open task manager, you are seeing all the processes of your application. But if you are within the user space, you will be able to see only the tasks of what is running in that user space, not the other user spaces. Are we getting the whole point? So if I run a task manager within this, I'll be seeing only this and whatever this container requires to run, right? And here in this container, each container or each isolated user space, what it will get? It will get its own process tree, its own hardware, and its own networking capabilities. What does the individual system get? Its own hard disk, its own CPU, its own network, right? So see what user space is getting. It also gets the same thing. But the only difference is your physical machine gets the actual stuff. Here you get the logical stuff. Here you get the logical stuff. Now, how is this concept actually possible? Okay. So let us understand with these 3 examples. I'm not sure whether it is clear to the people sitting in the exactly in the last row, but let me try to explain. The first one which you are seeing is your Linux file system, because it starts with root, the forward slash, and then you are seeing drives like dev, etc, lib, proc, all of that. Okay, and then you have something called as process tree. You have something called as process tree, and then you have some of the networking capabilities, and you have some of the networking capabilities. Let us try to understand how this concept is applicable to container. All right. So this is a file system, right? Okay. The colored boxes are your containers, right? And within the container system, where did the file system start from? Again, it is starting from the root. Is this root the actual root? No. That is the root of your user space. So for the application which is running within this container, it is seeing a file system which starts from root. Avuna kada? For an application that is running within this container, it is seeing a file system which starts from root. So application has every right to believe that it has its own system altogether. Yes or no? For the application which is running within this user space, right, it is seeing the drive system which is from root. So it will see all the drives that are necessary for it. So it will see that, okay, I'm running in a Linux machine. That's how your applications feel, right? So every container, the actual path might be something. If you take the actual path from your system, it might be var, lib, docker, some folder underneath it. Okay, but for the application running within it, a file system is created. A local file system for an user space is created, which again starts from root. So anything which you do here, okay, you are actually using your operating system, because at the end of the day they will be stored logically under some drive. But for the application, how does it feel? It feels like I am working on operating system altogether, because I have a file system which starts from root. See 3 containers or whatever containers. Every container is starting from root. So for every container, the file system it has its own file system. Is it a physical file system? No, it is a logical file system. ఎందుకంటే actual physical file system అంటే ఏంటి? Slash var lib some folder paths underneath it, and again you are seeing slash. Right? This is a physical path. But what is the logical stuff to these containers? Every container is getting its own file systems, right? Now let us apply the same logic to process. So here we will have process tree. What is a process tree actually? So what is this? A desktop, right? Desktop in Windows is called as an explorer process, right? So for example, if I double click and open Chrome, for this Chrome to be launched like this, you need an explorer process. So what is a process tree? Explorer plus Chrome. Explorer is the parent and Chrome is the child process, right? If you don't have Explorer, you cannot be able to launch the Chrome, right? Are you seeing the relation? For every process that is being launched, there will be something which is parent, which is parent. You will have individual process, and processes can be lined up as trees. Now let us go back to this. In Linux, whenever you start, a process called as zero is started. Zero is the basic process of Linux. Let us understand that, right? And then don't get by what is that base process and all of that. Let us go just by numbers. A base process that is start with Linux. That starts two more processes, 1 and 2, which starts 4, 5, and some other stuffs, right? And now, basically, in this case, 5 is your container process. 5 is your container process. So, to your actual operating system, container is a process. Now let us get inside the container. Inside the container, where is it starting again from? 0. I have written 5.0 to just understand that it is a fifth process child, right? So it is again starting from 0. So to the application that is running inside this container, it is seeing all the process tree. It is seeing all the process tree, just like how it behaves, how it is basically being felt in your operating system, right? Does it make sense now? So every user space is getting its file system which starts from root. Every user space or every container is getting a process which starts from 0. That is what your operating system gives. Container is also giving that, right? So to the application which is running inside this container, there is nothing that needs to be changed, because it is getting file system, it is getting the process tree, and it can do its job, right? Now, one thing to remember, 5.0 cannot control something like 3.1. A process which is inside some container cannot control any process which is outside its boundary. Okay, so that's why I've just put this explicitly. Can we do this? No, it is not possible at all, because 5.0 has nothing or no awareness of what is happening in 3. What is happening in 3, right? Okay, important stuff, right? How are this happening? How is this possible at all? In Linux, there is a concept called as namespace. There is a concept called as namespace, and to be very specific, there are some kernel namespaces. To get this, the namespace which helps us is called as PID namespace, or a process ID namespace. All right, there are many namespaces. So PID namespace for process, net namespace for networking, right? Mount namespace for your hard disk, for your file systems, okay? And then the user namespace for users within your basic abstractions which you are trying to create. So container technology is using a Linux concepts, which are these namespaces. Which are these namespaces, right? And what do they get? They basically get these abstractions, right? So for the application which is running within this container, does it look as if it is running on an operating system or not? Yes. Okay, is it logical now? All these days I was saying that in the container you will get whatever you want, right? You will get whatever you want, because this is how it works, right? Good. Now, before this, someone was asking me a question: how can I do capacity planning, or basically monitoring of the Docker containers, and if some memory increase has to happen, how can I do all of that? So for that, Linux has one more concept which is called as C groups. Using the C groups, you can give RAM increase or allocate RAM dynamically to your containers to your processes. This is again a Linux concept. Namespace is a core Linux concept. C group is a core Linux concept, right? And now the last one. Generally, we have sudo user. What is sudo user? Administrator, right? And whenever you become an admin, you get all of many permissions, right? But let us assume that I want only networking for that application. The permission which I want is networking. Okay. See what happens. You get only a capability of network binding service, not the other stuffs. So you don't give sudos, but rather you will be giving capabilities. Okay. This is not something which we do. This is something which Docker engine gives to processes. This is something which Docker engine gives to process. It will not give sudo capabilities. It will give only sudo, all the sudo permissions. It will give capabilities. Capability is a specialized area where you get permissions. So if I attach this capnet bind service, what would happen is for that process, it will get all the permissions that are required to open or stop or open ports and all of that, right? Similarly, if you are seeing audit control, I get a control on that audits, whatever we have. Ch own, ownership of the files and folders. So in Linux, any things which you do, you have broken down those things into capabilities, and you can assign individual capabilities rather than giving a root permissions or not root sudo permissions to the user. Just give what he wants. Just give what he wants. So three basic concepts. One is namespace. The other one is C group. The third one is capabilities. Capabilities doesn't come into play very much often, so that's why I have just one slide on that. But most of the things happen via namespaces. Namespaces. So in container, you are getting basic file system. Now let us just get inside this. Whatever we have built, Docker run, okay, minus IT, right? Nginx slash bin slash. See the file system. Is it starting from root? Yes. But is it an actual root? It is just root to this container, not your operating system. So every container which you start will have something like this. Will have something like this. Now, okay. Now let me run this command. Docker starts. So it will tell every container what is the memory percentage, what is the network percentage, what is the CPU percentage which it is using. And now to this container, whatever we have run, it has given 990 MB. What is the 990 MB? 990 MB is not the container's memory. It is a free memory on your operating system. It is a free memory on your operating system. Earlier, when we started Docker, we had to give fixed memories, and then whenever we wanted to increase, you had to use that C group concept. But now it is quite simple. Okay, Docker can choose on its own. But if you want to fix the limit, saying that I want this container to be always running with 2 GB of memory, then you do that C group. Otherwise, there is no need for you to worry about it. It can be dynamic enough. It can basically take like how your processes are taking. For example, whenever you are running your system, an antivirus scan happens. Antivirus utilizes 99% of your whatever CPU or RAM or whatever it is. Once it is done, it will come down. Okay. Now even Dockers are like that. Even containers are like that. When they are utilizing, they will go to the peak. When they are not, they might share that memory, because memory is not there. Memory is the parent operating systems, so they can share with other containers. This is the flexibility that it is added recently, but earlier every container when you started had a fixed memory. Okay, whether you are using it or not using it, that was consumed. Okay, now it will just consume the minimal footprint. See how much our container is using: 448 KB. That's it. That's the RAM which it is using, right? So every application within the container, what will it get? It will get its own process tree. It will get its own file system. It will get its own networking capabilities, right? So now Docker, I'm using one more command, inspect. I'm passing the container ID. Okay, and if you see, Docker is also getting some networking attributes. Okay, Don't worry about the command, we'll be learning that. But if you are seeing, if my Docker has an IP address, has an IP address. That's the whole point. So each container is getting whatever you expect for a physical machine, whatever you expect for an operating system. Are they all physical? No, they are all virtual. The network which you are seeing over here is virtual network. The file system which you are seeing within this container is a virtual file system. The process tree which you are seeing within the container is a virtual process tree. So everything is virtual, but your applications will get whatever is required for them to run, right? So within the container, whatever you want is your choice, your application, right? Now container is all about applications. Do you agree to that? Yes. So using the container, can I create a Ubuntu image, Docker? Is it possible? Yes. How? Is Ubuntu an application? OS. But what is Docker all about? Okay. Now, what is the difference between Ubuntu and Linux kernel? What is the difference actually? What will be different? What will Ubuntu or Red Hat add to the basic Linux kernel? That is what they do, right? Ubuntu operating system aina, Red Hat operating system aina, what will they do? So for the people who don't know Ubuntu and Linux, Red Hat technology, let me simplify it. You know Oxygen OS, right? OnePlus phones. Okay, is it Android? Yes. Okay. But why it is called as Oxygen? They take the Android and they do customizations. Yes or no? Similarly, Ubuntu or Red Hat are the same thing. They take the Linux kernel and they do the customizations. And now, when they do the customizations, what will they do? What will they add actually? So you will get some extra executables. Where will executables be? So in Linux, in Ubuntu, you are using something like apt get install. Can I execute the same command on Linux kernel? No. Yes. If it is no, then how is it working on Ubuntu? So let me tell you this question. In your system, okay, if I double click on DOC document, Microsoft Word is opening. In my system, if I try to do, nothing is happening. What is the difference? Software is installed. What do you actually mean by software installation? When we install the software, what will happen? I want a very basic stuff. Ante chala layman. I know that I don't know service. The only thing which I know is hard disk and file system. Can you explain what will happen? Files will be copied into specific locations. Yes or no? Right? So Linux kernel and Ubuntu, if I basically compare, what are they? What is the difference? File systems. So in the Ubuntu, whenever you install, you will get many different folders and many different files which are on top of Linux kernel, which can do additional capabilities. Yes or no? Yes. Yeah. Do I have a file abstraction over here? Yes. Do I have my own file tree? And in this root, whatever you are seeing, if I copy the Ubuntu file system, this container will suddenly behave as if it is Ubuntu. Do you agree to that? Yes. In this, if I copy the CentOS, whatever CentOS is required on the file system, it will behave as if it is a CentOS operating system. Yes or no? So in this containers, which are basically for applications, you can also use it for the minimal operating system stuffs. Why? Because we have our own file system. We have our own file system. Now let me go to the Docker Hub and show you something interesting. Did you got my point? Right? So if you double click on a Word document, you are getting, because there is Microsoft Word.exe somewhere in your system, and in my system I don't have Word.exe. So what is the actual difference? In your system there are some additional files which I don't have on my system. So that's why it is not working. That is the logical stuff, right? So similarly, with the Linux kernel and the Ubuntu operating system, you will have some files extra or some folders extra. That's it. Nothing beyond it. All right. Now let me go to the Docker Hub. Okay, and search something called as, do I have Ubuntu image over here? Yes. Okay. Now let us look at Docker file. So if you see what they are trying to do, they have some tar file. And if you go through all of these run commands, okay, they will untar that file and they will just set the file system. You take the CentOS image, that's the same. Okay, you have a tar image, you untar it, you get the file system, right? And then you set up the basic process environment variables and all of that, and you get this. So shall we use the Ubuntu image, Ubuntu container image? Even though Docker is for applications, it is possible for you to also think about OSS because it has file system, it has process tree, right? But generally in your offices you might be using Ubuntu CentOS as a base images, not basically for it. For example, if I want to install Tomcat, I can take from Ubuntu. Okay, apt get install Tomcat 7 in the run statement, so I'm getting the Tomcat install. That's how it is. So now can I do this now? Docker pull Ubuntu, okay, colon, I give latest, whatever is latest shall come up. Or if you want to be very much specific, what you can also do is see at the tags what is the version which you want, right? So what is latest? Latest is 18.04, all right, but let me take 16. So 16 dot, yeah, it might be slightly very less size compared to what your actual operating systems are. Docker images, see what is the size of Ubuntu? 114 MB, which means this is not complete Ubuntu. This will have only very basic things that are required. If you want anything in addition to that, you can install. If you want anything in addition to that, you can install. So let me do this. Shall we run the container? And I want to get inside the Ubuntu image. So Docker run -it. I want to get inside, right? My image's name is Ubuntu colon 16.04. And while I am getting inside that, I am using a shell or bash prompt. So bin slash, okay, I have to get install tree -y. Okay, it is unable to locate the package, which means add apt repositories also you should do. Okay, so let me try to do some one more installation. What is the other thing? They are very basic, they don't have many capabilities. You, whenever you are doing any packages, you have to add apt repository and then do it. It will know very minimal things, all right? So but at least apt-get is working now. It is saying that I am unable to do the things, but it is working at least, right? Let me do ip config. Ip config is not working, but if you can do something called as apt-get install ip utils, I think, if I'm not wrong. Okay, so then you will get all the ping capabilities on this machine, so you can do that sort of things, right? It is possible for you to see some operating systems in the Docker images. That is just because you have a file system. You have a file system, and on top of that file system, they take the Ubuntu tar, they untar it, and they set some environment variables, and suddenly your container behaves as if it is Ubuntu. The same thing for other operating systems also. Making sense, right? Good. One last thing. What is the base image here? Scratch. Scratch is the image which will give you very basic file system. It will give Linux kernel, to be very specific. Whenever you use Scratch, you get Linux kernel, right? That is the only image which basically Docker Inc. or the Docker company has built, and rest of all the images are based out of this. So this is a parent of all the images, right? Any image if you take, if you track the parent tree, so it will go and end up at some point to Scratch. So for example, I use Nginx. Nginx uses some more image, some more images uses that, and if you track all to the parent, okay, Brahmotsavam సినిమాలో మహేష్ బాబు చేస్తాడు కదా 7 తరాలని, right? If you try to do the same thing on this, you will go and hit the scratch, right? That is a basic container which Docker comes up with. Okay, in Linux world, you take any container, and if you track the tree, hereditary tree, it will go and hit the scratch, right? You cannot use any other. If someone asks that, can't I create my own image and I don't want to use any existing images, then the answer for it is use a base image which is scratch. So what is a scratch? Scratch is a very lightweight Linux kernel, right? Making sense, right? So in Docker, whenever we create container, what is that we are getting? We are getting illusions. I'll call it as a illusion to understand. Illusion for your application, all right? And a Brahma, right? For your application, what would happen is it is seeing its own process tree, it is seeing its own file system, it is seeing its own networking capabilities. So application thinks that it is running in an operating system, but actually it is not, right? But your application gets full respect there because that is the only thing that is running. For example, if you take a laptop and you on that laptop you are just using Chrome, nothing else. So Chrome is the most respected application there, right? Because the whole purpose of laptop is that. Now we are giving that respect borders for all of our applications. All the CPU, most of our CPU to our application, most of our RAM to our application, most of our hard disk spaces that are utilized to our applications. That's why your application suddenly perform better when they are running inside the container, because they are getting special attention. Whatever you do in this container is for that application. That's the whole point, right? Is it now better than yesterday? Now what is inside the container? So inside the container we have process, we have file system, and we have network. And these networks are not something which are from system. They look as if they are newly created for us. They are separate, but actually are they separate? No, they are virtual, not real. Okay, so file system is a virtual file system, process tree is a virtual process tree, and the network is a virtual network. Okay, how are these things created? By using a concept called as namespace. That's the whole idea. That's how these containers are working. All right, now go ahead with, if you have any questions, you can ask me. Okay, so let me come back. Uh, okay, while we can use Docker in VMware environment or AWS, Docker can be installed anywhere Docker engine is present, and Docker engine can be installed on any Linux machine, any Mac machine, or any Windows machine. It doesn't matter whether you are running in AWS or Azure. It doesn't matter. VMware, physical machine, nothing at all. The only thing that matters is these operating systems, not actually where those operating systems are present, right? So it doesn't matter whether it is VMware, whether it is cloud, or I use AWS because I get a free machine there, right? That's the whole point, right? Docker file is creating an image and container both in one go. No, Docker file, whenever you build, you will get an image, you will get an image, and whenever you use Docker run command, you will get the container. Docker build gives you image, Docker run gets you, makes container out of the image. That's how it is. Like user space, containers can also communicate with each other, The user space is something which basically gives a feel like as if it is an operating system boundary, right? Can I communicate between two operating systems running in the same network? Yes or no? Yes. So if your two containers are in the same virtual network, they can communicate with each other, but they cannot directly communicate. They have to communicate via networking. So you are on your front machine in your office, how do you communicate? Using network. The same thing over here. Whenever you want to communicate between multiple containers, it happens via networking. All right, since it is not a physical network, we'll be learning about virtual networks. All right, file system of the base container is equal. In the slide var, there is a base, but there is no container. Can you allow? Nothing like that. So base file has its own whatever it is. Okay, పేరెంట్ ఆపరేటింగ్ సిస్టమ్ లో మీకు ఏదో ఫైల్ సిస్టమ్ ఉంది, బట్ within the container Irrespective of what is there in your file parent system, you will start again from root, right? So what is there in the parent does not affect what is there inside the container, because in container your file system is mandated by your image, whatever image which you have chosen, right? So I think that's what it is. OS speaks with kernel using a shell. OS speaks with kernel using a shell. I don't think so. All right. So shell is a way for the user to communicate with the kernel. If my definition of kernel is of terminal is right, terminal is a way for the user to communicate to the kernel. Right. For the other exes to speak with kernel, you don't need terminal. There are C APIs. They speak in the C language. All of the Linux is in C. Right. These guys speak with each other using that. Yeah. Okay. What OS adds to the kernel? Additional capabilities. For example, kernel is very basic, right? For example, you want to connect touch screen. Kernel doesn't have those capabilities. So what will you do? Your operating system might have some drivers which can add basically an input screen. And whenever you touch into the input screen, whatever instructions that are into the input onto the touch screen will be converted into OS instructions first, and then OS speaks with a very important layer of its own, which is kernel. That's how it is. So operating system is an interface between the kernel and you, between the basic kernel and us. That's how it is. Right. How things will work on production environment? They will work no different. They are exactly like this. Right? Because you will not be working on single system. You will be working with multiple physical machines which has multiple Docker containers across the network, right? So I don't think so there will be anything that is different. It depends on how you define your network. It depends on how you have given your containers, the CPUs and the other things which it requires. Okay, so there is no different than really thinking of it differently, right? Yeah. Since you said that one container cannot control the other container, can't we access each other? Controlling is different than accessing. Controlling ante ఓకే యా కంట్రోలింగ్ అంటే మీరు పొద్దున్నే లేచి ఇడ్లీ అయితేనని చెప్పటం. యాక్సెసింగ్ అంటే తిన్నావా అని అడగటం. దానికి దీనికి చాలా తేడా ఉంది కదా. యాక్సెసింగ్ ఈజ్ యువర్ ఆస్కింగ్, కంట్రోలింగ్ ఈజ్ యువర్ డిమాండింగ్, రైట్? డిమాండ్ ఈజ్ నాట్ పాసిబుల్. Accessing is possible via network, just like how two machines communicate, right? Yeah. Can't we define C groups while creating the container? You can do that. So Docker run, yesterday what is that I have said? There is a Docker CLI reference. Docker run, have you seen all the command line arguments? Hare Krishna, please look at that. You will find an option called as -- memory there. Docker run, while you are running your container, can pass something called as -- memory, and in that memory pass 2 GB there. So your container will be running with 2 GB. How that works internally? It uses C group, right? But it is possible. For that you have to go through all the command line arguments of the commands, right? Okay. So we can think of user space is something like multiple users logging into the same machine. Multiple users logging into the same machine is multiple users logging into the same user space, right? So for example, I have taken a machine, I have created 2 users for you and me. When you log in or when I log in, we are logging into the same user space, right? But when the guest logs in, he logs in into the different user space, okay, which has nothing in common between you and what we are doing and what he is doing. Okay, most of the Linux systems generally have not more than 2 user spaces. They don't create it a lot. Container is the only technology which creates a user space for every application. That's how it is, right? Okay, not a very heavily used area in the operating system industry, but from the moment the container has came, this user space is very heavily used area, right? Okay. Okay, can we think of, I think I've said lambda in AWS. I'm not getting the context, but it has nothing to do. Lambda is a serverless programming. It has nothing to do with containers. Yeah, lambda can internally call containers. That's a different story of how it is implemented, but lambda has nothing to do with this. right? Container network inherited from parent, I would not say inherited, I would say a virtual network created on your operating system, right? So we'll understand that, don't worry about it. So Docker networking is a virtual network on your laptop, is a virtual network on your laptop, right? Are there any limitations that we can place only specific type of application is possible to be? I think I have said this restriction already. You can put any service based application, any application which is something like a service, let it be hosted via HTTP or TCP or whatever it is. You cannot put desktop applications in containers. That's the only restriction, right? Okay. Each container will have separate IP, obviously it should, right? Yeah. Docker is used mostly for simulating production environments, not mostly. That is one of the many use cases that Docker has, right? For the companies where it is difficult to simulate, they use it. I would not say that is the only thing. Yeah. Okay. How to get container IP address? Wait 2 more days. Yeah. మన నెట్వర్కింగ్ గురించి మాట్లాడుకుంటామండి, అప్పుడు మాట్లాడదాం. మీకు లేదో ఇంకా ఇఫ్ యు ఆర్ keen to know how to basically know the IP address of it, Docker inspect and give the container name or container ID and see through all the parameters, you will be finding something called as IP address there. Okay, fine. Yeah, any other questions in the room? Okay then, so let us stop it at that. Yes. Hmm. Hmm. That is because you are using port forwarding. Okay, so we have just defined the network, then we will go to the port forward. Yeah, thanks guys. The questions I'm, when you will share the use cases, first let us finish the concepts now. Don't be in a rush. You have paid me to deliver all of that. మీకు డైరెక్ట్ గా యూస్ కేసులు కావాలని నాకు 3 రోజులు అయిపోద్ది డాక్టర్, నాకు అదే సోకం, రైట్? సో ఇవన్నీ లేకుండా యూస్ కేసుల గురించి మాట్లాడినా మీకు అర్థం అవుదేమో, right? Use case is very simple. Take any application, create a container, put it in Kubernetes. That's a very simple use case. The only thing that differs is your application, whether you take a Java application or whether you take a Node application. That's what differs. But the thing is, for us to do that, we need to understand all of this, otherwise it will become very difficult, right? I'm out of location from Bangalore. Whom I need to contact Satish, right? Cute qualitythought.in@gmail.com. Just mail to him or call to quality thoughts number and he will lift the call, right? Thanks guys.